There is a new super impressive open access multimodal model that has recently landed, and that is something that everybody has been talking about. This model is called LLAVA, LLAVA. It's a combination of Llama plus the clip encoder, and this model has got its first version couple of months back, but the latest update to this model is completely shocking everybody, and a lot of people are calling this open source. I would like to first say that even though this model has got open access, it still follows Llama 2 license. That does not mean complete open source, but still it is not like a closed model like GPT-4, and that would also result in more fine-tuned models of the same. So this video we're going to discuss two things. First thing we're going to discuss is how, when this model landed 3 months back, how did it look, what are the techniques that they discuss, and now we're going to see the latest model and what kind of benchmarks look like, and we're going to see the live demo and some GPT-4 version versus this model comparison. Let's get started. The paper is called the Improved Baselines with Visual Instruction Tuning. And let me first quickly show you a demo before even I move forward. So I've got Lava, and inside Lava you can upload this picture. This picture is from the famous GPT-4 demo. So what is unusual about this image? And it says the unusual aspect of this image is that the man is ironing clothes while standing on the back of a moving car. This is not a typical scene, as ironing out clothes usually is done indoor and in a more controlled environment. The man's ability to maintain balance and perform this task while the car is in motion is quite remarkable and unconventional. So when you uploaded this image, it gives this detail. It's as simple as that. You upload, ask a question, have a conversation. So that's what this model is about. So now what is this LLAVA? The LLAVA stands for Large Language and Vision Assistant. And the place where it started from is a paper that was released in somewhere in April 2023. So what they have done with this particular paper is they have explored couple of options, and this paper particularly contributes to different things. One is that they are presenting a new visual instruction tuning. So a multimodal instruction following data. So typically if you see the instruction fine tuning, or SFT, supervised fine tuning, has been happening only in the large language model LLM space, but now they are trying to port this into the LMM space, the large multimodal model space. That's the first thing that they are doing. So they have released the data set as well. We can see a sample of that multimodal instruction following data that they have got from ChatGPT/GPT-4. The second one is they are also releasing the large MMM. So the large multimodal model, which is like a new model that they launched with the clip visual encoder and the language decoder of Llama. So they've combined these two and created this LMM. So now this is what happened in April, and at the time itself it had like remarkable abilities. You can go through the paper and then you can see how they are doing every single thing, and you can also see what kind of outputs it gave. So you can upload an image, ask question, and then it would give a response. And they also compared it with the models at that time, GPT-4, Blip2, OpenFlamingo, and all these things. But now what has happened is couple of days back, this paper has got a new revision. So on 5th October, this paper has got a new revision that says improved baselines with visual instruction tuning. And if you see this model, if you see this chart, whenever you see the one at the outer part of the circle is like the best. So if you see that, the red color is Lava 1.5. The orange color is the Qwen VL chat from Alibaba Cloud. Instruct Blip and Blip 2. I think they're probably from Salesforce. I'm not very sure. I don't remember, but we have already done an image capturing comparison using Blip2 as well on this channel. So if you compare it with all these models, you can see the red color line being on the outer, the best outer circle, and that means like this is one of the best models, the large multimodal models that are available in the open source world, like leaving the GPT-4 outside, in the open access world. And you can see what they're claiming is that this model, what the model that they're releasing, the Lava, the latest Lava version 1.5 is has got the state of the art across 11 benchmarks. Across this 11 benchmarks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did I count 11 or 12? Okay. Across 11 benchmarks, they're saying that they have got the state of the art performance, and their 13 billion parameter checkpoint just uses 1.2 million of publicly available data, and the training was finished in 1 day on a single node, like a GPU cluster of 8 A100 node. And the point that they are trying to make is, if even if you compare it with a model like Qwen VL Chat, this has used a lot of data, like tons of data, and their model does not use that much of data. Still, it is producing tremendous result, and that's why one of the reason why a lot of people are quite excited about this model in itself. So if you see this model, the latest model is called Llama 1.5. That's the latest version, and you can go ahead and then see how this model performs across benchmarks. And you can, you get to see like different aspects of it. The latest one seems to be using Vicuna 13 billion parameter model for the LLM part, and you can see the scores that it has got across benchmarks. This is the previous Llama that they had, I guess, and you can compare it with Qwen VL Chat, and you can also compare it with Edifex. Edifex is the multimodal model that was released by Hugging Face, which we already covered. Qwen VL Chat is the multimodal model that was released by Alibaba Cloud, and these are like the classical image captioning model that we had before all these things began. So if you see this thing, if you compare it with Blip 2, for example, on VQA, that is a benchmark, this has scored 80, while Blip 2 had scored 41. And even if you compare it with Edifex, Edifex had scored 60, and this Llama 1.5 has scored 80. And you can go on and then see, when you compare Edifex with Viz, you can see Edifex has scored 80 billion parameter model, has scored 36, while Llama 1.5, I guess this is mostly the 13 billion parameter model, has scored 53. So overall, across a lot of benchmarks, this model is quite good, and you can see certain samples here. Like for example, if you upload this picture and then say, you can ask a question. If there are factual errors in this question, point it out. If not, answer the question. What is happening in the desert? It says, I cannot answer the question as there is no context about which desert are you referring to. And then it gives an answer, and you can, okay, so this is the answer from GPT-4. This is the answer from Llama, and this is the answer from Llama 1.5. It directly says there are no deserts in the image. The next one is a test that we did when we did the GPT-4 test, GPT-4 vision test. You upload an image and you ask it to return it in JSON. So we can say, please read the text in this image and return the following information. Return the information in the JSON format. Note, put XXX is a placeholder, and if the information is not available, put NA, not available there. And you can see this is the format that we are asking. We are basically saying wherever you have XXX, fill in the data, and if you see, if you do not have like the data, put NA there. And this is what the GPT-4's response is, and this is Llama's response, and this is Llama 1.5's response. So if you compare Llama 1.5 and Llama, so for example, let's take one of the items here. So the GPT-4 says the name of the card holder is card holder, IMA card holder, and here name, IMA card holder, name, here Llama had said Amy. Now if you see the date of the birth, it's 8th month 31 1977, date of the birth 8th month 31 1977, 8th month 31 1977. So if you see here, Llama 1.5 has made a mistake. I think it has confused with 23 somewhere, and it has said instead of 31 it has said 23. And as you can see that this model is still not like as same as GPT-4 in certain cases, but the point here is that you have got a model that performs really good when you compare it with all the other open access models. And you can go ahead and then see a lot of details here, but I think the most impressive part of this is the computational cost. For Llama 1.5, we use the same pre-training dataset of this one, which they have used, and you can see more about the pre-training dataset. A subset of 558,000 image pairs from Lion CC SBU with blip captions. So you can see the same thing here as well. So if you go to the Hugging Face model where the model is uploaded, the training dataset has got 558 filtered image text pairs from this Lion dataset, captioned by blip. So basically what they do is they take the images, they use blip to caption it. So this is how you create the image and text pairs. And then they've got 158 GPT generated multimodal instruction following data. This is what we started seeing at the start of the video, that they started creating an instruction data for multimodal data, and they've got 450,000 academic oriented VQA data mixture. So this is separate. And then finally they've got 40,000 shared GPT data. So they have all these data as part of this thing. And if you see this thing with that, due to the increased image input and the resolution is 338 pixel, the training of Lava 1.5 is 2 times more than the Lava, the model. So Lava, when you compare it with the Lava, this Lava 1.5 has taken 2 times more. So it's 6 hours of pre-training, 20 hours of visual instruction tuning using a node, a GPU node of or cluster of 8 A100s. This is quite impressive in the age where, you know, these models get trained for days and days, especially when you are talking about like a multimodal model that is like beating all the benchmarks. I think this is a very impressive piece for the amount of data. First of all, it has lesser data when you compare it with like other solutions like Qwen, and it has been trained on a faster GPU, or it took lesser time to be trained. This is all very impressive pieces. Now what we can do is, I would strongly encourage you to go read it and you know, just get to know what is happening. But at the core, you have got a large language model. The large language model in this particular case is Vicuna 13 billion parameter model, the 1.5. And to connect it with the vision part, you have got the clip vision encoder, clip wit L, that is a vision encoder, and this is being connected by an MLP layer. I think multi-layer perceptron is the MLP layer. So that is how this has been connected. And when we discussed in the last video, yesterday's video, and we discussed about the brain decoding, we learned about the contrastive learning image. That is what the clip model is. Basically, it's got like image text pair, and then it tries to connect these images together, and that has been one of the core fundamentals of all the things that are happening around us, like stable diffusion, like these large multimodal models. So the code and the model are already available for you to use. You can go here, click Lava, and you can see the entire data available here. All the informations are available here. How do you use it? Everything is available here. But if you want to see the instruction data set, that is something that I found quite interesting. You can go to this data set and you can go click here and you can see this. So this is the image. For the given image, you can see the instruction is available here. What is the position of the sketchboard in the image? And then it has the output. And then you can see how the conversational or the instruction data for multimodal cause is being built here. So you can take a look at this, and if you want to use as well, you can use it. The only catch is the model comes with the Llama license. That also means, you know, you have got like the different aspect of above 700 million MAU. You cannot use it. It's a weird one, but anyways, you can you can still use it, like if you're a hobbyist or a small company. Now let's jump into the demo. So you can go click the demo here and then access the demo. That's one option, the easiest option. Or the model is also already available on Hugging Face. So soon somebody is going to create Hugging Face spaces. The model is totally approximately 13 GB. I've not tried to fit it in on Google Colab yet, but that is something that I might do it for the next video. I'm still yet to cover QuenVL, but we already have a new model that has beaten QuenVL. If we go to the model and then see upload an image, this is the first one that we tried. I have uploaded one more image. I don't know how many of you know cricket. Cricket is a game played with bat and ball, and you have got 11 players in one team mostly. So if there is a bowler bowling, you have got like rest of the 10 members in the team. And whenever you see an image like this, you know that this is, first of all, they are wearing white colored dress. That means it's a test match. And then if you see an aggressive position, if you see a fielding position like this, it's a very aggressive or attacking fielding position. Now I uploaded this image and I said explain this. It explains this image. So it says the image depicts a group of men playing a game of cricket, and it gives on the details, like the ball is visible in the scene. It says additionally there are two sports balls on the field, which is not right. And it talks about baseball and all these things. It has kind of got it incorrect. The reason why I'm bringing up this image is because I got a very good result on ChatGPT with this. By comparing this with ChatGPT, I don't want you to think that I'm trying to diminish the success or the value that this model is bringing. I just want to have like a comparison between what I consider to be the best in the multimodal world with the best open access multimodal model. It doesn't mean this model is bad. It just means that open world has a lot of catch up to do, but it will happen. So the point here is that this is the response of Lava 1.5. And if you go here and then if you check, you can see when I uploaded the same image and I just said explain this, the same prompt, it says this is an image of cricket match. Here is what is happening. It says the fielding setup and it says this type of fielding is aggressive fielding. So usually seen when the fielding side is looking for wickets and the batsman might edge the ball. It goes on to extreme details about, you can actually build like a commentary system with this thing. That's the main thing that I wanted to highlight as a biggest difference. I know this model has scored really good on benchmarks. It is also possible that there is a lot of multimodal instruction fine tuning which might have had that synthetic data aligned with the benchmarks. Yet this model is quite impressive because Matt Schumer recently had a viral tweet thread where Matt had uploaded this image and said, okay, I saw this picture and it looks delicious. Can you come up with a shopping list and a recipe for me to cook? It gave all this information here. It's quite impressive. It says based on the image, the dish consists of salmon, lemon slices, herbs. So you can see these are the 3 items and what you can cook with this. The next one is it can solve captchas, as you can see here. Upload it and it can solve captcha. And to some extent, it can write code. Even I didn't like the code that GPT-4 created when we explored it. And can it detect what coin is it looking at? What coin is this? This is United States penny, which features an image of Abraham Lincoln. And finally, what breed of dog is this? The dog in the image is Bernese Mountain Dog. So it is good. The model is good. Even when we are going to do some tests, let's upload the image, and I can ask this image. Let's say what is this image? I think this is an image that I tried. Let's upload this. What is this image? Send it. I'm not sure if it is going to pick up the conversation from there. Okay, it picked up the image. The image features a man holding 2 cell phones in hands, showcasing the difference between them. One of the cell phones is an Apple iPhone, while the other is a Samsung Galaxy. The man is likely comparing the 2 devices, possibly discussing the features. This is definitely very impressive. This is a YouTube thumbnail, and it does a very good point and explaining the man is probably comparing the phones, and it also says the man is holding the other one is a Samsung Galaxy, which is not true. Both of the phones in this case are particularly iPhone, but yeah, that's what it is. The next image that I wanted to upload in this particular case is upload this image. Can you get the text of it? Send it, and then let's see what happens. So I've uploaded the image. The image is being uploaded. This is one of the iconic books. I love this book. Someday I want to create a content that says automate the boring stuff with AI. That is a content that I always want to make, but it says, okay, I am sorry, I cannot image because I can describe the content. The image features a robot mowing a lawn while the grass is covered field in the background, and the robot is pulling a mower. There is a person nearby, possibly observing or assisting the robot. The scene appears to be a cartoon or illustration, possibly from a book or a comic. Let's go here and then upload the same image. Let's upload it. The same robot image. I can just literally copy from there. Yeah. What's this image? Get the text of it and send it. Once we send it, ideally I'm expecting it to just give me the text, automate the boring stuff. Okay, it kind of it goes on to say the second edition, the name of the author, Al Schweigert, and it's a very well-known book. GPT-4 acknowledges that the cover features a cartoon illustration of a robot mowing a lawn. So Lava 1.5 does a good job in describing the picture, but it is still not as close as GPT-4. But this is one of the best open access models that we have today, and you can see a lot of different benchmarks how Lava 1.5 has done. And like I said, Lava as a model stands for large language and vision assistant. So we have got large language and vision assistant, a combination of either Llama or Vicuna as the language part, and using the clip encoder for the vision part and combining them with like an MLP layer, and that is how this entire setup is done. Quite impressive that they have managed to share the paper. the model weights, the fine instruction fine tune data, and also all the informations are available inside this GitHub repository. Please check it out. See you in another video. Happy prompting.